This is a short video of construct validity for structural equation modeling when using AMOS. Two of the fit indices that you'll need, your residual correlation and your standardized residual correlation, will not be on your AMOS output. You actually are going to have to take data from AMOS, put it into Excel, and then calculate these fit indices. And I'm going to show you how to do that very easily in this video. We're going to use two models. We're going to use the measurement model and the Harman single factor model to get the data that we need to get our residual correlation and our standardized residual correlation. So I'm going to go out to AMOS and show you how I'll do this. So I have two screens open here. I have my AMOS open on the left, and I have an Excel spreadsheet on the right, and I already have some workbooks here, worksheets named. So the first thing I'm going to get are my sample moments, and I'm going to do that from my measurement model, which I have here. Run my model and view my output, and I'm going to get my sample moments, correlations, sample correlations, and I'm just going to copy this whole thing here, and I have to do Control-C on my computer. You might be able to right click, I'm not able to, and then Control-V, and so I have that in here. Then I need to get my implied measurement, and I'm going to get that in this same output under my estimates matrices and my implied correlations. So I'm going to get all of these. I went too far. And I'm going to paste those into this worksheet. And then my residuals worksheet is where I'm going to calculate the my values that I need for my residual correlation and my standardized. And all I've done here is copied. Now I need to, since I copied all of it, I need to take out my factors because I only want my items. And these first four on mine are factors. So I'm just going to delete those and make sure I have the same on my, I need to make sure that they match up because they don't come out on my sample moments. And I want to make sure that my cells are matched up. So my first cell is actually B2 and it's my item RC3, and that does match up. Now that I've made sure these matched up, all I did was copy my items the way they are in here and pasted them into my residuals measurement spreadsheet, so I'd have those. Now I'm going to put formulas in, and this is going to be really easy. What I'm going to say is I want this cell to equal, and this is my B2 of sample moments minus B2 of implied, and it is 0 because they were both 1. But here's the beauty of Excel. If you look, there's a square at the bottom of that cell that's green. And if I grab that square and I go down and over, probably really doesn't matter what order other than here. Maybe I can't do it all at once. I need to do it in one go. This has automatically put the formula in for me. So if you look up here on this bar where the formula was put in, oops, we'll do the escape. It automatically made these B3, C5, D6. So calculated that for me. So very simple. Save. I always believe in saving as I go. So now I need to go back to AMOS and do my Harman single factor model. And the trick to this is do not start with a clean slate, because you need your items to come out in the same order. And if you take a clean slate and you start drawing, if you don't draw it in exactly the same order you drew your measurement model, your factors are not going to come out in the same order, and we're going to have a problem because our residual Harmons are going to come out from taking the implied Harmon from the sample moment of the measurement model. So we need the items to come out in the same order. So what I'm going to do is I have this model saved, and I'm going to use 80 as my factor in my single factor. So I'm going to delete my other factors, and then I'm just going to draw my paths to all three of these, and then save that. And now I have both of those models saved. So I'm just going to run my model and then get my text output. And again, I'm going to get my implied. That's all I'm getting from this one because I'm using the same sample moments that I used earlier. So estimates, matrice, implied correlations. And again, I have to remember I copied my factors with my items. So I will need to delete those. Looks like I gathered like all of it, didn't I? That's okay, I'll just delete it. Just go down and delete everything. And so I'm gonna delete just the one factor, because this time there's only one factor in there. There's not all four. And then I have B2, and remember, I'm just gonna double check, I have B2 is the first cell. So again, I am going to copy the headers. Oops, I need to move those down because I remember in my first one I had a blank cell there because I didn't copy it that time. So remember, just be real careful to make sure that your cells do match up, or your data is going to be, all of your figures are going to be wrong. And again, I'm going to put in my formula. So you get to see this again, equals, very simple, all the way back to sample moments. B2 minus implied Harmon, B2, enter, I have my formula there, and so I can just copy this over. So really, really simple. You don't have to go in and retype formulas, which could take a really long time. On my residuals measurement sheet, worksheet, I'm going to start by looking at my residual correlations. And I want these to be between, I want my values to be between 0.1 and negative 0.1. So I need to know if there are any values that are greater than 0.10 or less than negative 0.10. And I need to know how many there are. So what I'm going to do is I'm going to start with some conditional formatting because I want to see a visual. I'm just going to change that to 0.10. There are two. Okay, so I can type 2, or if there were a lot, I would put a formula in there to do that for me. Let's see if we have a lot on this one. I can show you how to put in a formula. Conditioning format. Highlight them if they're less than negative 0.10. And so I only have 2 there as well. So really, that's a good turnout. But let me show you how you could put this formula in here to make it easy for you, just in case you do have a lot. Okay, so in this cell, I'm going to put in a formula that's called COUNTIF. And I know COUNTIF, and it wants the range. So this range is, I can do that, or I could just type that cell colon that cell. And I want it to tell me if any of these are less than negative 0.10. Okay, see there's 2. And then I would just highlight those, auto sum, and there are my 4. Okay, so I know that for my measurement model I have 4. I will do the same on my residuals Harmon spreadsheet to find how many there are on that model. But I also need to find my standardized residual correlation values on both models. How many I have, and this is similar, that it needs to be within. So we want to know if we have any greater than 2.58 or any smaller than negative 2.58. And then my total. And again, I'm doing the same thing on both of these models. It's just I'm going to show you this one on the Harmon model. And we're going to do it the same way. I'm going to say conditional formatting, highlight rules greater than 2.58. I didn't have any, so that's good. And I'll do this one as a COUNTIF on these cells. They are less than negative 2.58. And again, I had 0. So these are great. So I had a total of 0. I've never had that happen. That's really good. I'm going to show you one last piece of this analysis, and that is going to be the average variance extracted and the composite reliability. And you're going to do this for each factor. So for each factor, you're going to get the implied correlation for each of the items. So for this factor, I'm going to go out to my data, my implied correlation. So with what was it? Because I was deleting it, right? Here we go. Remember, I had my 4 factors up there. So for A1, it was 0.748. For A2, A2, 718, and for A3, it's 0.734. Okay, now I have formulas in here already. And so let me show you what I have. So this is just saying the absolute value of the loading. So none of them were negative, so it's just the same. So that just says equal B3. Then the loading squared. So I have equals this C3 squared. So once I have these formulas in here, remember I can just click and drag to copy them over. And then the reliability, 1 minus D3 gives me this. Okay? And then these numbers are going to move down here. So I need the sum of the loadings squared. I'll type that for you. So that's just these 3. The equal sum. This is the loading squared, which is the variance extracted divided by the number of items to give me the average. This is the sum of the reliability. And this number is the sum of the reliability squared divided by the sum of the reliability squared plus the variance extracted, okay, or extracted variance. And then the square root of the average variance extracted. So I typed these here for you, so if you wanted to maybe print this page, you can remember where to get all of these numbers. And you do that for each of your factors for the items. And so you'll see I have a spreadsheet down here for each of them. And I said that was the last thing, but it's not. There's one more thing that I'll show you. And this is the likelihood ratio test. And this is where we're going to take the chi-square and degrees of freedom and the p-value for the harmony and the measurement. And then you'll see I'm just subtracting them. And then this is the chi-square distribution. And that's just a function that you can put in from your menu on Excel to get these numbers. And that concludes what I wanted to show you on the validity and reliability. I think the biggest takeaway, I hope, was that you saw how easy it is if you accidentally delete a formula, how easy it is to get those back. So I hope you found this helpful, and I wish you luck on your structured equation model.